All right, here we go. We're going to talk about increasing and decreasing constant intervals. I always compare when we talk about increasing and decreasing constant intervals like roller coasters, all right, because you constantly go up and down, and that's the way I look at graphs. When we have this right here, a graph like this, in order to figure out if a value is increasing, what we do is we start from left to right. All right, so we're always comparing a value A with a value B. All right, and the value B is always going to be greater than the value A, and these are your x values. Okay, now if a function is increasing, when you compare these values, that means that the y values, or f of x, that means f of A, when you compare them, is going to be less than f of B. So the value preceding it is going to be larger than the value before. So in this, you can see that, okay, where is that occurring? Well, any A to B value, as you go from left to right, you see that your y values, so these are your y values are increasing on this interval because you can see the y values are going up. Now, what interval is this increasing? Well, the interval is referring to the x values. So the interval that we see is going to be an open interval, and if you're not sure what open interval is this interval notation where they're not part of the interval. When you use parentheses, they're not part of the interval. All right, and because at this point right here, which appears to be at the x value of -2, from -2 to 2, all right, we would say this function is increasing. Now, in the same way, or a similar way, I should say, if we have a decreasing interval, we once again look from x values from A, B is going to be larger, and our y value, where it's increasing or decreasing, f of A will be greater than f of B. So when you go left to right, you notice that the values are going down, all right? They are decreasing. So the values of the function are decreasing. Well, on this function, if you go left to right, I don't see any values that are decreasing. So on this function or this graph, there are no decreasing intervals. A constant interval, okay, a constant interval is where, once again, take your x values, A always has to be less than B, all right? And where y values, where we notice that f of A will equal f of B because it's constant on that values, all right, so constant. Now, where do we have constant intervals here? If you look at left to right, you notice that every single one of these values from here to here are constant, and it's going that way. So we're going from -infinity to it appears -2. This is where it's going to be constant. We also see that occurring right here. So we have another constant interval, all right, from 2 to infinity, all right? We don't include the 2, and we don't include the infinity, or we don't have brackets or anything by the infinity because those are not actual values. Brackets, when you use interval notation, means it is part of the interval. It is equal to. The union combines two separated intervals together. Okay, well, let's try some of these problems. And we're going to go through some things. We're going to try to identify this graphically. We can use a graph utility, but we're actually going to graph this by hand and figure out what these values are. So we're going to practice using piecewise functions, and we're going to find out where we have increasing and decreasing in constant intervals. Okay, so first off, what we have is this is a piecewise function. Okay, a piecewise function has different pieces to it. So piecewise, all right, function has different pieces to it. And what we need to do is we need to graph each of the individual pieces. So the first piece, what we have is a line, 7/3 x. And we're going to graph this right here. So starting at, I always start with the end of the domain for that function. So we're going to start at 3. Now 3, you notice, all right, is all the values that include this are going to be less than or equal to 3. So when I plug 3 into this function, I get out 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay? So as I plug in 3 into here, I get a 7 value, and it's going to be a closed circle, all right there. Now, because we're talking about values that are less than 3, I need one more point because it is a line. So I need 2 points, all right, to create a line. And so I'm going to pick another value. So in this one, I pick 3, and I'm also going to pick 0. So that's the easiest. I plug in 0, I get 0 as well. All right, so I'm going to use a different color here. Red, and pick the dots, and we have, all right, our graph, right, first line. Now we have to do our next line. The next line is going to be 7. Now 7 is a constant. Now if you go from 7, all right, right here, is going to be used, and it's going to be the values from 3, but not including 3, to 7. Well, whenever you do this, you always use the endpoints and plot those points. They're either going to be an open or closed circle. In here, we're going to have an open circle at 3, so at 3, we're going to write 7. Well, if you notice, and do that, it's actually filled in by the previous graph, so it's going to be a closed, but it is open at this value, so this will be an open circle. All right. Now here, I want to plug in 7, so 3, 4, 5, 6, 7. We see right here, we're going to get 7 as well. And we have that right there. Okay. All right. Now, I guess while we're doing this, we can kill 2 birds with 1 stone, because in this problem, we need to graph at the function and determine visually where the function is increasing, decreasing, constant. So I guess since we're here already, before we finish the graph, we do have one more value, but I'm jumping around. I apologize about that. But let's determine what we got so far. In our first equation, which is right there, we realize that the values are increasing because the slope is positive. So we actually have an increasing interval from, well, negative infinity, because everything less, and up to 3. So it's going to be increasing from negative infinity to 3. We notice then at the next part is that this next segment from 3, which is right there, all right, 3 to 7, we realize our values are the same. So I guess this would be a constant interval. And it's constant from 3, open interval, to 7. So all the x values from 3 to 7, that's where my y values will be constant. Well, let's find out the last section, and we'll graph this one. All right, this last one. And we'll plug in, once again, I'm going to plug in my endpoints. So this is going to be an open circle. All right, I'm going to plug in 7. When I plug in 7, I should get 7 as well. All right, and that's going to be an open circle, but notice that it's closed by the other one, so it's going to be right there. And I'm going to plug in one more value, something semi-easy. I guess we could plug in 14. 14 would be pretty good. X equals 14. 7 will cancel out. We're left with 2, so it'll be 4. All right, so 2 sevenths times 14 plus 9, so 2, 4, so it'll be 5. All right, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and we're going to have a value of 5. All right, so I'll go 5, 1, 2, 3, 4, 5, and roughly about right here, give or take, and graph that value. It's another line. Okay, so this last section, all right, what is happening on this last interval right here? Well, it appears on this interval is decreasing, obviously, because the slope is negative, it is going down, and it is decreasing on the interval, starting at 7, because the interval is the x values, going from 7 to negative infinity. Oh, sorry, not 7 to negative infinity, 7 to infinity, because it's from 7, where you're using all the other x values, and those values, all right, that you get as outputs are going down. All right. Well, should we try one more? Well, why not? All right. So there's where we found the increasing, decreasing, constant intervals. We'll try one more. All right. This is also a piecewise function. All right. We're going to graph this. In graphing this, we have another piecewise. And we look at the directions, use a graph utility, which is a calculator. But I don't have one with me right now, and I don't want to use it. But then we graph this function, we'll find out the intervals, all right, which is the x values where it increase, decrease, here, and constant. All right, so we'll graph this first. So graphing the piecewise, graph one piece at a time. All right, and this one, if you have this, we're going to start that. I'll use red for my graph. And we can plug in some values. So in this one, we're starting at this endpoint, so we'll start at negative 2. Okay, so at negative 2, it's going to be closed. And I plug in negative 2 in here. So if you want to find the negative 2, what we have is at negative 2, 1, 2. We will get 2, 1. Square root of 1 is 1, and mean negative 4. 1, 2, 3, 4. Right there. All right. next part, what we can do is we can graph another point, okay? And with this point right here, we can plug in, I don't know, probably like -3 or something, all right? Or -5. Let's plug -5, all right? -5 might work out. And the reason why I picked -5, I plug it in there, is I think it might work out to be pretty nice. The square root -5, this would be negative, so it'd be turned to plus. -1 would be 4, which would be 2. -5 would give me -3. All right, so -5 out of -3, which is right there. And it will be going like so. Okay, that is that first graph. The next one, all right here. And well, let's see. What is happening on this interval from here to here? Well, as we look at here, what is happening? Going left to right, we notice that the graph, the values are actually going decreasing. So at least starting right here, all right, we have a decreasing interval, decreasing from -infinity, that's where it starts, over here, -infinity, all the way up to, it appears, going to be -2. All right, -2. Now we'll see if we have to change this up a little bit, but we'll have the first part. This next one we have is a parabola. So once again, I'm going to start here. It's going to be an open circle. We have that. So when I plug in -2 into there, what I have is -4. So it's actually be, all right, open, but the other one closes it. And then what I have then is a parabola. Plug in 0, and then I plug in 2. It's going to be over here at -4. And we have this parabola looking like this. All right. Okay. So figuring out the original rest of the story, we have this next part. So what is happening here? Well, from -2, it appears that this values are going up. And then it hits the maximum or vertex of the parabola at 0. So it is increasing. The graph is increasing from -2 to 0. Then you notice that, whoa, it's going down. And it keeps on going down all the way to the end. And so as we travel along our x-axis and keep on plugging in numbers, we know this graph is going to be decreasing. Where is it decreasing? The x values we're using, we're going from 0, starting at 0 right here. All right, and as we plug in some additional values along the x, we realize that our y values are going down. So how far can we go? Well, as x goes to infinity, all right, that's where we have our decreasing interval. And as x goes from -2 to 0, it's increasing. And as x goes to -infinity to -2, it is decreasing again. All right, so we just went through 2 problems explaining how we can identify where functions are decreasing, increasing, and constant. Went through piecewise graphs and how to graph them. I hope this helps you do some of your homework and understanding how to identify graphically increasing, decreasing, constant intervals.